Yeah, good afternoon, all the participants. We would like to start our regional workshop. The title is Circular Economy from Concept to Practice. We have three distinguished speakers. I would like to introduce one by one. We start with Prof. Sadan from Sadan Goes. He's a professor at the Center for Sustainable Development and Resource Efficiency Management. Prof. Sadan, can you turn on your video? Prof. Sadan. Okay. So he's also a coordinator for Center for Sustainable Development and Resource Efficiency Management at Mechanical Engineering, Jadavpur University, India. All the speakers have 20 minutes for presentation. So please, Prof. Sadan, and then followed by Q&A at the end. So we can start with Prof. Sadan first to keep the time is still on time. So please, Prof. Sadan, the time is yours, please.
Thank you.
You can, yeah.
I like to share my screen.
Yes. Okay.
Is that coming?
Yeah.
Yeah.
Can you make it a
sure
slideshow? Yeah, full screen. Yeah,
sure.
Please. Okay. Good.
Very good afternoon. And Dr. Adisman and my colleagues, speakers here. Today, I'll speak on the circular economy and what is circular economy and how in India we are implementing this circular economy concept into reality. To go into it, these are my topics of interest today. I'll just go for some of the introduction, then what is happening in India, issues and challenges, and way forward. If we look into this table, we will find that there are a lot of scopes in different countries where the resource circulation is not taking place, and there can be a very big improvement in those areas. Like if we look into the countries in Asia Pacific, you will find that the scope is more. Of course, there are countries like Nigeria, Lebanon, they are having very poor state of affairs in this waste management, even Egypt. But on the other hand, in Asia, as well as in European country, there are some countries who are having a very good activity with respect to the resource circulation. Like if we talk about Korea, Republic of Korea, they have a target of 3% by 2020. But I'm quite sure that due to COVID-19 pandemic situation, this year, the recycling rate has come down, but they are going ahead of it and they are doing very well. If we talk about Italy and many countries in Europe, we will find that the waste going to the sink, the landfill, is at a lower rate and lower stage. So in that way, they are taking the advantage of recycling. If we look into India, for last couple of years, around 6-7 years, India is improving a lot with respect to the resources circulation, and Previously, it was more than 70%, but today, the waste which we are going to landfill is less than 55%. So that is because of some initiative which has been taken in India. I'll talk to that particularly. But why we are thinking of recirculation? Because we have a fixed amount of resources, and the material is used, and after some time, at the end of its life, the material is thrown away. But you know that those materials which are thrown away are really a scope for us to retake those materials into our resource reservoir or resource repository as a material for use in the other process. Like, and in that way we are losing our opportunities. And I have given some of the data. If we talk about the plastic, out of 8.3 billion tons of total plastic ever produced, we are only going for the 9% recycling. And there are huge scope for plastic recycling. And why I have put the plastics in the focal point, because the plastic is one of the very important issues today, which are creating number of problems, including the problems in the marine environment. Marine littering and microplastic are the two words which are now thinking. I mean, most of the people throughout the world are thinking on these two words and how to tackle this, because microplastic, when it is created in the marine environment, ultimately it comes to the stomach of the human body and also the animal, which creates a lot of issues like carcinoma and many other diseases. So this is one of the very important issue for which we have to think of the recyclability and recycling and the circulation of the resources. We think of material will used, and then either it is thrown away or recycling, and then go ahead with this. So, but on the other hand, there is a new thought process that instead of using the material and going for the recycling, the first we have to think that reduce the use of material. We call it the reduction in the consumption pattern. For the same type of production, the material which is used today as X gram is to be reduced to X minus Y gram. And that is the reduction at source. So if we start from reduction at source, and then the material which has a Y life, if we design and redesign the material and the product in such a way that the life extended to Y plus Z, then the possibility of going the material to the disposal site will be lesser. So these are the thought process which has come up, and we call it the upstream measurement. So here we call this as a resource efficiency. So the material which you are using, for consuming, and if you go on using this for quite a long time, then your resource efficiency will be definitely increased. And we are going ahead with this concept in circular economy. So there are a number of definitions of circular economy, but this is one of the circular economy which I have developed last year. And you know that any material which in very easy word, any material which is used for manufacturing a single product, at the end of its lifetime, instead of disposing it to landfill and others, that material will be used as a input material for the second process. So when the first process is ended, the use is end. At the disposal stage, the material which was used in the X process will be now used for a Y process, and this material will act as an input material or the raw material. So in that way, this will go on cycling, and that's why we call it as a closed loop cycle. And this closed loop cycle, at each of the cycle, this material and the process is creating an economy. This economy generates employment. This economy reduces the resource consumption. This economy reduces the load on the landfill site and many other things. This will reduce the marine littering as well as the microplastics generation, and so on and so forth. So this is the, and moreover, this will reduce the greenhouse gas emission. So of course there are some debate of greenhouse gas emission reduction or not, but as a matter of fact, the whole process in circular economy gives us a positive thought process as well as a very positive work with respect to the resource circulation is concerned. And these are some of the points: the lighter material with extended life, consumption of energy processes is low, reduction in generation of waste, manual intervention is less, flow or steps in the manufacturing processes will be lesser, and packaging should be reduced, cycle time will be reduced, and reduce resource consumption by reusing, and many more. So in that way, this is the principle of 3R and of course the circular economy. So these principles, if we look into and analyze these principles one by one, we will see that this is not only enhancing the life of the material, the acceptability of material, but also at the end, this will reduce the cost of the material, cost of the process, cost of the product. So in that way, the marketability of the product is concerned, this will also help. And this is one of my model that whenever we talk about circular economy, we must be concerned about the whole of the supply chain, whole of the process. It should not be thought of that the material will be recycled and the circular economy will be implemented, the resource circulation will be done and the resource efficiency. No, we have to start from the idea generation. So whenever a product is thought of for production, then at the conceptual level, we have to thought of that the circular economy concept has to be implemented. And thus, I'm not going into detail of that. So this is the starting point, and this is the starting point of the supply chain of the manufacturing and the use. And each of the stages, the eco design of the product, manufacturing process should be smart, energy should be spent less, and it should be it should have a reusability and recyclability, and ultimately it should be tend to the zero disposal, and whatever are generated, it should go for the use in as a input material, which we call sometimes the reverse cycle. Now let us come to India. India, in last couple of years, as was referring, that Swachh Bharat mission and Swachh Sarvekshan has demonstrated the 3R and circular economy implementation. These are the two pictures. If we can see that this is the dumping year, not only in India, in many of the countries in Asia Pacific, in African countries, this is the situation. In India, today the concept is that we will go for a circular economy society, and we will contribute to Swachh means cleanliness. So we will contribute to
Prof. Sadan, we can hear you. Yeah. Prof. Sadan.
Arisman,
Yeah, it looks like we lost Prof. Sadan.
Yes.
Uh,
Do you want me to start my presentation and then come back to Professor Ghosh after we've reconnected?
yeah, looks like he has a problem with connection. Maybe let's see if we cannot wait. Yeah, please.
Otherwise, we can wait a few minutes. It's up to you.
Yeah. Looks like the internet connection from him because I don't see him in the room. So, okay. Yeah, I think we can jump to you, Prof. Michelle, because maybe Prof. doesn't have problem with his connection. So let's continue with you. Maybe he can join again later. Please share your PowerPoint.
Thank you.
Yeah.
Okay, can you hear me, Arisman?
Yes, yes. We can hear you.
Presentation?
Yes, yes, please go ahead.
Thank you.
Yeah, it's your time, please.
Thank you very much. Thank you, everybody, for joining us today for this really interesting workshop on circular economy. My talk today is going to be about digital technology and circular economy, and unfortunately, digital economy sometimes fails us, the digital technology, but I think the digital technology can offer us a number of ways in which to improve circular economy outcomes and to help us to work on the development of the challenges involved in the circular economy, as well as moving towards decarbonisation and much more resource efficiency. Australia has a number of very significant sustainability challenges. One of them is going to be climate change, and that could have a very significant impact on our agricultural production, and water scarcity, which is a very important issue in a dry climate. We also have significant problems associated with biodiversity conservation and land use change, and that will be further impacted also by climate change. Job creation is a very significant one for us in Australia. We're a very young country with a fairly heavy focus on agricultural and mining production, which tends to be high capital use and low human capital use. We have a very significant use of fossil fuels, and renewable energy is a fairly small part of our overall total power production, about 21% in 2019. And we've had fairly slow political will to move towards greenhouse gas emission management in Australia over the last 10 years, and that's slowly starting to change. But that's been some of the challenges that I guess we have faced. So the digital economy starts to afford Australia and the world some opportunities for perhaps much more focus on the circular economy and potentially the achievement of some of the important goals of increased resource efficiency and less carbon and reduced waste management or improved waste management across the board. So in this presentation today, I'd like to look at the digital technology and information technology realm and its potential for improving Australia in particular's reference to circular economy outcomes. So when we think of circular economy or the digital economy, we think of options like banking and buying and selling goods online on Amazon. This year in COVID conditions, we've had many university and high school students, primary school students accessing their education just online. And for those of us with a mobile phone, we know that our ability to have entertainment and economic options for banking and talking with our friends through this amazing ability to take our mobile communication systems with us. So this space is really rapidly changing and going to afford us, I think, a lot more opportunity for managing climate and circular economy outcomes into the future. There's a report called the Global E-Sustainability Initiative, Smarter 2030 ICT Solutions, ICT being information and communication technologies. And it was produced in 2015, and it suggested that ICT technology can reduce global carbon emissions by about 20% by 2030, which is really a wonderful opportunity and only 10 years away. And specifically, the Smarter 2030 modelling suggested that in Australia, e-commerce could save something like 250 million litres of transport fuel. E-work could free up about 12 billion Australian dollars in capital expenditure through the reduced need for infrastructure. E-health could support an additional 7 million people a year to engage with health professionals more efficiently, and the potential to reduce about 13,000 kilometres of electricity grid infrastructure by the move towards increased focus on digital technology and hybridisation of our electricity and renewable energy systems. Very importantly, this report suggested that ICT technologies could reduce Australia's emissions of carbon by about 27% by 2030. This is very interesting given that Australia committed to reduce their emissions by about 27% by 2030 in order to meet the 2005 baseline for the COP21 meeting in Paris. So it's suggesting, therefore, that if we invested in these ICT technologies, in this digital technology world, we could just through digital technology reduce Australia's overall carbon footprint. So the potential for this is really significant. The key elements of the digital technology that we often think about include artificial intelligence and automation, big data management, geospatial information, asset tagging, cybersecurity, the Internet of Things, which we're all familiar with, e-commerce, Amazon and eBay, blockchain development, and user security with your smartphones, and of course, the application technologies that we know well through Uber and Airbnb. The important element also when we start to look at circular economy is how do we improve the way we live in cities? And as more and more people move to the city for living, how do we use this digital enablement of circular economy in the ways we function in a city? How do we improve our energy and water use, our energy and water efficiency? How do we improve our waste management, reduce our waste load? And how do we improve the way we share services and infrastructure in order to reduce the need for that physical infrastructure? And carpooling is a really big example here in Australia. I spend 50 minutes getting to the office in the morning and 50 minutes in the evening. And I travel about 20 odd kilometres to the office, to the university. And in that, I'm probably seeing a couple of thousand cars as I travel to the office, and most of them have only one person in them. We're all travelling singly to the office. Husband and wives often can't share their carpool because they're going in often in different directions. And we don't have a very big public transport structure in Australia. So as a result, we're all in our cars. But that ability alone in a city environment to start focusing on that ability to carpool and car share is going to have a very significant impact on our carbon use. The World Economic Forum estimated that over $1 trillion per year by 2025 could be saved by looking at the adoption of circular economy principles. This would involve things like waste production being reduced, improving our overall resource efficiency, and increasing the circularity of the resources of waste we currently produce. The WEF also said that, as Professor Ghosh said in his introduction to his presentation, 95% of plastic packaging material with a value of about $80 to $120 billion is lost every year to the economy, just on single-use plastics. And yet we've had the recycling symbol in our economic dialogue for about 40 years, but only we have so far about 14% of plastic packaging actually being physically recycled. So that's an alarming 72% of the total plastic we produce not being recovered at all, 40% of that making its way to landfill, and that other 32% going into our river and marine and natural environments. So it's really, really sad. And we haven't really moved on that yet. And yet that's what the ultimate goal of the circular economy will be to do. On the right-hand side of my chart, it gives us an opportunity to reflect on the value of that waste recovery, plastics and beyond plastics, to the Australian economy alone. And in this chart that was prepared, it shows that for Australia, there's at least $12.6 billion in waste management services available with the development of the circular economy. We can save about $3 billion through the sale of recovered materials. We can look at waste-related activities adding a further $7 billion to our economic growth every year. For every 10,000 tonnes of waste produced or recycled, we can create another 9 jobs. And overall, it's suggesting that this is important also because our waste is contributing about 2% overall to our greenhouse gas emissions in Australia. So the circular economy itself, as a model of economic growth, has significant potential in Australia. On this chart, it shows that we know the pillars of the circular economy focused on the need to balance our ecology and our equity in our economy. But there are also a couple of other parameters which help us to move down the path of circular economy. And that's the sort of systems where we start to need to focus on their management. So systems like ISO 9001, which is looking at quality management systems for our production, ISO 45001, which is starting to look at our management standards for occupational health and safety, and very importantly, ISO 14001, which is about trying to set standards for our environmental management. That and our focus on life cycle assessment and our ability to actually assess the impacts and the footprint of what we're doing will help us move down this path of, I guess, circularising our production systems. Circularising the production systems in Australia. This next slide shows a report that was done this year by KPMG consultants on looking at where the low-hanging fruit was for the development of the Australian circular economy. And in it, we showed that there was a couple of main focuses, 1 in food production, 2 in transport, and 3 in the built environment. And superficially, looking at the food environment, it's about taking our food waste and either converting it into organic fertilisers or potentially producing renewable energy biogas from it, improving our water footprint, and certainly reducing the consumption of our waste that we produce waste food from. From a transport perspective, it's about the use of electric vehicles and the transition towards a lot more carpooling and car sharing. And from a construction or built environment point of view, it's about seeing much smaller dwellings, much more compact dwellings in our city environments so that we don't have very large footprints in the way we live, and increasing the energy efficiency of the buildings in which we live. So when you look at those potential low-hanging fruit outcomes, they're not that difficult to achieve, and certainly with a lot of good planning, they are something that can make a very big difference to our overall footprint. This slide shows some of the potential value of these ideas and how they might be actionable in the Australian economy. I think what we have to accept with the digital economy and its enablement of the circular economy is that it's not just this move towards low carbon economy that's important. It's the fact that the digital technology and circular economy will make our economies more resilient and ability to also take some of the tough challenges that we might face with climate change. It's about being able to reduce very significantly our overall footprint with a particular focus on energy, transport, and our overall resource consumption. Importantly, in young countries like Indonesia and India, and certainly even here in Australia, job creation is a very important element. In Australia, we've got an ageing population, and as a result, physical support, mobility, and health support via digital technology is going to be very critical. And as we know, the ability to be here today with much less footprint than holding a conference, we're able to share our own thoughts on digital technology and circular economy advantages with an Indonesian, an Indian, and a Japanese audience. So the digital technology framework is going to provide us with some really exciting opportunities to reduce our footprint and to see a lot more circular economy being taken up. This slide shows the impact of Australia's greenhouse gas emissions, which are quite significant at 535 million tonne. We're only a population of 26 million people, so we still have, I think, the highest per capita emissions of CO2 in the world, which is not a good reputation. And you can see that most of our emissions are coming from our electricity production, from fossil fuel, coal, and the direct combustion of our fuels in our transport sector. And Australia is a very large country, and therefore, like I said earlier, many of us are spending a lot of time in the car getting to our jobs. We're also here in Perth, a long way from Sydney and Melbourne, a 4-hour flight, so our reliance on air transport also results in a significant footprint. So that energy production and transport footprint is something we've really got to be focused on and looking towards circular principles to improve. This chart shows the digital technology's role in potentially helping us to reduce our emissions and enables a lot more carbon abatement. And you can see the focus there is that for Australia, it's focused on smart agriculture, the ability to look at also smart manufacturing, and the electricity grid is another important one for us to focus on. So this value from the digital technology is also going to look at the ability to save time, become a lot more resource efficient, and for businesses also to improve their overall revenue and profit collection. E-commerce in Australia is also going to allow us to share a lot more businesses and see an e-commerce develop much more quickly. The benefits for us as consumers, it was estimated by Deloitte that there's something like $9.5 billion of consumer advantages for the Australian economy. To me, it's more about, as an economist, bringing together a lot more options for business and job creation, as well as reducing our footprint, and the ability also through the blockchain for products and suppliers to be able to demonstrate their sustainability and their footprint of the products and the services they're producing. That element of the blockchain, I think, is certainly going to open up a lot more opportunities for circular economy into the future as well. And this year, 2020, has surprisingly shown the ability of the digital economy to actually harness and improve our resilience as economies, because it's given us this ability to talk and still function and produce during a pandemic shutdown. I'd just quickly here like to go through some of the initiatives that the Australian government has gone through in relation to digital technology. And we had, in fact, this year, the inaugural national meeting of the digital economy and technology here in Australia as a way of looking at how DT can improve our overall ability to function as an economy and certainly reduce and to improve the sustainability impacts. Government procurement's another area, and also, very importantly, artificial intelligence and autonomous systems. And I'm going to go through an example of an autonomous system that's quite characteristic of Australia in the mining application very soon. But the ability for the Australian government to focus on these sorts of initiatives is also an important way of suggesting that governments can have a very important role in helping to pave the way for circular economy focus. We've also developed in Australia fairly recently a national blockchain roadmap to show where blockchain can help us in circularising the economy. And very importantly, in 2018, the federal government developed a national framework for waste management that will be focused specifically on trying to look at how local government, who largely manage waste in Australia, can improve the resource recovery and recycling outcomes at a national level. This next slide is a small video that I took myself on a mine site in Western Australia, about 1,300 kilometres north of Perth. And it's an industry initiative that is utilising GPS technology to make mining equipment autonomous. And in this, we can see a very large mining truck. I think it's a Komatsu 930, which is a very large vehicle, as you'll see. It weighs about 230 metric tonne empty. And when it's got its iron ore payload on it, it goes up to about 570 metric tonnes. So it's a very big vehicle. You don't want to be standing in front of it if you can't stop. It's costing about 7 to 8 million Australian dollars. And one tyre on this truck weighs about 3 metric tonne alone and costs between 80 and 100,000 Australian dollars. So this is a very significant capital cost. And yet currently those 4 tyres, when they finish their work life, which is, I think they're replaced about every 6 months, they go to landfill. They're not recovered for their rubber, and unfortunately they go to landfill. I think there is some new technology that's looking at a way of burning them to provide some energy, but I'm not sure, in fact, that's the highest value use for those tyres. But the new autonomous technology that's being developed will enable those tyres to extend their work life by about 25 to 30%. And the actual truck machinery as well. So let me just share this video with you to show the size and scale of this machinery and the fact that this truck, as it passes me by, has no driver at the wheel. It's been driven from a GPS centre here in Perth, 1,300 kilometres away. So it feels somewhat eerie when the truck's driving by and you can see the size and scale of the truck. realise there's no one driving it. Okay, let me take you to the next slide. You can see the size of this truck. There's the engineer in the bottom right-hand corner, and that's a very significant capital investment. So what the circular economy can bring to us and what digital technology is helping us to enable is that when we drive these trucks autonomously, we improve the precision of the way in which they're being driven. There's less human error. They're able to hold their course, so the wear and tear on the tyre and the machinery is less. There's less maintenance, and therefore the truck lasts much longer. So it might have a 5-6 year life, but that life will be extended using this GPS digital technology. In addition, hopefully remanufacturing within the circular economy will also help to see much more value from that truck going forward. These are a couple of examples of where the circular economy initiatives are being applied in Australia currently. We've got lots of recycling facilities. We've got lots of government starting to look at how we can improve the way we see the circular economy operating locally. And there are a few examples also, including the last one, which I like very much, which is a national focus in looking at how we modernise our recycling facilities across Australia. So as I looked at earlier, if we look at the main benefits of using digital technology to improve our circular outcomes in Australia, we're tending to focus on it from a smart agriculture, smart manufacturing, smart energy, smart buildings, from an e-health, e-learning, e-work and a smart mobility perspective. And I think it just goes to show you that when we start to categorise these industry opportunities and make them much easier to understand, we can start to see the circular benefits, not just improving the efficiency of our economy, improving potentially the profitability and the job creation, but most importantly, from a circular economy perspective, we start to improve the ability for us to focus on how we improve the digital technology in improving the overall carbon and greenhouse gas emissions that we have, which is what the circular economy hopes to achieve. Okay, thank you very much for your time. I hope that I've been able to add something further to the very good presentation that Professor Ghosh had given us on introducing us to the circular economy theory. And I hope that that lesson has given you some potential ideas for where, even in Australia, we're starting to pick up on the benefits of the circular economy. Thank you, Alyssa.
Yeah, thank you, Prof. Michelle, for sharing with us the Australian experience applying the circular economy, especially when you mentioned about the circular city or smart city, how to use the digital technology and Internet of Things to apply the circular economy. Can we move to another speaker, Prof. Sadan?
I'm
yeah,
here.
Please. Yeah, now it's yours again.
Yeah, only thing is that you have to make the slide share.
Okay, Annie, can you share? You mean you need a permit for present your presentation,
No,
or you
no,
want?
no. I want you to share from your office.
Okay, okay. Annie, can you share the PowerPoint? Prof. Sadan PowerPoint, yeah. Yeah, just a second. Annie? Yeah, just a second.
Sure.
Yeah.
But so much a planning point from Michelle.
Okay, now it's ready. Prof. Sadan, please.
Yeah. So please, previous.
Okay.
Yeah, that's all. Yeah. Next.
Okay.
Next. That's all.
Okay.
Yeah. So I was here. So I was just referring to what is basically circular economy. And as a matter of fact, as Michelle was also telling, that anything which can be used as a second process, as an input of the first material, this brings different type of business, and circular economy is the behind of all these processes. Next. Next, please. Next, please.
Next, please. Yeah.
Yeah. So these are some of the benefit from the circular economy, like material weight will be lighter and with extended life, consumption of energy. I mean, all the points we can see that there are beneficial aspects of the activities, and this will also bring business. In fact, it is a very important issue that whether it is a business of, whether it is a matter of waste management, or it is a matter of life cycle of any product, whether it is engineering or any other things, unless and otherwise there is a business model, it will not work. So circular economy is such an having such an aspect which really brings business into the activity. Business means there will be employment, there will be involvement of people, and there will be income over expenditure. Next. Next, I have already explained this thing, the model of circular economy. Next. Next. Yeah, here for implementation of the circular economy concept, any country needs a very robust policy and legislation. So what happens in India? India had number of legislation, but those were not effectively implemented, keeping in mind the circulation of the resources. Though we had the first effective legislation is EPA, Environment Protection Act 1986, but for a long time, we have observed that there must be some revision to focus on resource circulation. And that's why in 2016, in India, 6 waste management rules, including resource efficiency policy, it was the draft was released in 2019, and the battery waste management rule, it was draft released in 2020. So all these 7-8 rules is driving India's waste management as well as the circular economy movement. And today, India has a number of activity which can demonstrate that circular economy implementation is giving some benefit in the society, in the government, in the environment. Next. These are some of the photograph of processes, like say, this is on COVID-19 situation. There are huge amount of biomedical waste which are generated in the quarantine center, hospitals, and even the houses. So these are handled very carefully in different biomedical waste management plant. And this is one of the plant in Delhi, which I visited a few months back. They are operating very nicely. And of course, if there are any recyclable material which are coming after the autoclave or after the processing, then it is going very controlled manner and giving some recyclable materials and the product. Next. This is also a part of that particular factory. Next. The same factory. See the cleanliness of the factory, and we are really proud of implementation of the circular economy and cleanliness in some of the factories in India. And this is one of the example I was very much interested to show. Next. Now, the other part is the wastewater. Wastewater in India, huge amount of water was wasted from the processes. But today, for a couple of years, the recovery of different energy or different types of energy materials which are taking place in India. And as a matter of fact, the recovery of energy, recovery of nutrients, recovery of organic fertilizers, and also some of the reuses are now practiced in different parts of India. And also there are a number of research projects which are taking place in India for the recirculation of water, I mean, and the treatment of wastewater, including FSTP. Fecal sludge waste management is also a focus in India, which is taking place in most of the states in India now, and huge amount of, I mean, there are small plants where the power is generated from the sludge, and also through the pyrolysis process, there are some products which are generated, which are produced. So in that way, wastewater is one of the focus area for India now for the implementation of circular economy principles. Next. And these are the some of the recovery processes of water. There are a number of ways by which the water is wasted, but as a matter of fact, there are three main focus area which we are now concentrated on. One is the making fresh water out of this wastewater. The other is energy through biomethanation and others, and the third is the generation of the nutrients. Next. And ED, anaerobic digestion, is not only for the wastewater recovery process, but also this is now a part of Indian legislation, Solid Waste Management 2000 legislation, that waste, once it is generated, it should be segregated. And it should be processed either through anaerobic digestion or through composting or different energy recovery processes, like it should be converted into RDF, it should go to the cement plant, it should go for the co-processing. And finally, as I was showing the list, that 57% today, and our target in next 10 years is to reach 10% of the material to go to the landfill site, which is giving a boost to the waste management business sectors as a recovery process. And this is these plants are employing a big number of people in the processes. Next. Then, as I was referring to that co-processing, energy recovery process, co-processing is one of the focus area where India is focusing for treatment of the waste into cement plant. Cement plant is the best part of it. Next, the best part of is the whole of the waste converted into RDF. Next, whole of the waste converted into RDF, and then it is used as a AFR, alternative fuel and raw material. The RDF, which is once used in the cement plant, a part of it used for heating the cement plant, or rather the kiln, and the rest of the part, which is usually to be converted into the ash, but this ash is converted into the clinker, and finally it comes as a cement. So as a matter of fact, the waste which is coming to the cement plant, 100% utilization of that waste converting to energy and the cement. So that's why co-processing is now becoming a very popular in India, and this has a resource circulation of nearly 100%. So that's why 90% of the thermal energy which is used in traditional cement plant, we are now trying to convert or reduce this 90% to a greater extent by substituting the energy generation process with the help of the waste. So that is one of the very important and very significant example of circular economy implementation in India. And there are number of cement plants, at least more than 20 cement plants in India, who are now practicing this co-processing. And government of India, we are preparing and formalizing the rules, or it is already in the rules, but we are formalizing the business model so that all the power cement plants in India, they use at least a portion of the waste for co-processing in the cement kiln, and all the plants who are using power, they should get at least 5% of the power from the waste to energy plants which are nearby within 100 kilometer of it. So in that way, that is a very big challenge, as well as this is a very good solution towards the circulation of the waste in India. Next, go to, I mean, I don't have much time to spend on all those things. These are all a hierarchy. Now, the hierarchy is because previously co-processing was not in the hierarchy, but today co-processing is one of the very important and at the top position of the triangle of waste management hierarchy. So as a matter of fact, we are by the process tending, we are by the process is sending the waste to landfill at a very low amount. Maybe in a couple of years, the process of reducing the waste will be very low. Next. And the best part next. The best part of the co-processing is next. Best part of the co-processing is the types of waste, any types of waste which can be processed, and there are number of benefits in co-processing in cement plant. Next, there is a photograph where I have shown the points where the co-processing can be done as AFR feeding point in the cement plant, and this will really give a boost to the cement plant, because this will reduce the cost of power and reduce the fossil fuel use of fossil fuel. Next, these are the types of waste which can be used in co-processing, and if you see the list, there are a big list, and any types of waste, including the of course within the non-hazardous waste, it can be also hazardous waste. Some of the hazardous waste also can be used in the cement plant. Next, these are the pre-processing in the co-processing part, and of course it saves the coal energy from coal, and the more important is the energy from the waste is valuable, and it is significantly used in this process. Next. And if we see the sources of alternative raw material and fuel, next, we will find that in each of the places, if you look into it, in each of the places, you will find that there are sources of the alternative raw material for cement plant. So any types of waste which is generated at any of the location, any of the use, whether it is a manufacturing process, whether it is a municipal process, whether it is the CD waste, a part of CD waste, not all the CD waste, that can be used as an alternative fuel. Next, even the biomass, tire waste, hazardous waste, municipal solid waste, all these are applicable to be used as an alternative fuel in the cement plant. Next. And you know that as this is a very important issue and India has taken very seriously, that's why the efficiency of this co-processing depends on the TSR value. So in that way, by 2025, most of the cement plants in India has taken a target of TSR as 25%, whereas now they are running at say 12 to 15%, or sometime the highest is 18% TSR. So once the TSR is very high, the profitability of cement plant using this is very high. Next. This is also regarding TSR, and next I'll show the AFR coal savings and CO2. Of course, the coal saving is very high with respect to the higher CFR, and the GHG emission is also GHG emission reduction is also a part of this co-processing. Next, there are always a challenge in co-processing. So there are a number of challenges because the availability of right waste quality is a challenge in any of the municipalities. So the pre-processing for the co-processing is one of the very important issue, and it is a challenging issue for AFR process. Next, this is a plant photographs. This is possibly from Muddarpur plant, where cement plant is using co-processing. Next, this is a part. The other part is the SWOT survection. SWOT survection in India, which we started in 2016, we started with only 75 municipal cities to implement the effective waste management. And in 2020, in last 5 years, we have included 4,242 cities, and the system has been institutionalized with respect to the waste management is concerned. They segregate it, they process it like the rule says that after segregation, you take this waste, the municipal waste, mainly the wet waste for biomethanation, then composting, and then for some of the materials, including the recyclable waste to RDF, and then waste to energy. And again, the dry waste should go for the recycling. So this gives the municipal cities so much of boost that they are earning a lot of money out of this waste business. So now in 2020, we are very happy that 4,242 cities have a very effective waste management system in India. And that's why 2021, we are now looking forward for institutionalizing the system. That means it is a system, it is not a man-dependent one. And we are sure that in next 5 years' time, all the municipalities and the urban panchayats will be covered under this SWOT survection. SWOT survection today, it covers around 19 million people, and it covers 0.42 billion of people in India who are impacted by this SWOT survection and the effect of this waste management and the resource circulation. Next. So in that way, next few slides, I'll just show the indicators. I mean, SWOT survection gives a number of indicators, which gives the assessment by individual assessment by the third party, how much they are processing, what is the customers, consumers feedback and citizens feedback, what are the certifications they have received, and the service level progress, what type of service they are giving, and how much is the level of services which they are giving. So based on all these 4 areas and dividing these 4 areas into 7 or 8 indicator, it is assessed. Each of the cities are assessed, and just next, and you find that some of the photographs which I have shown, that these are the glimpses of different processes. It involves co-processing, it involves biomethanation, it involves the, that India and many other Asian countries and also African countries, we have informal sector of people who are working in the waste management as well as the formal sector. So making informal sector into formalization is a process, and we are doing it. On the other hand, not only municipal waste, but also the industrial waste as well as electronic waste and plastic waste. These are also the focal area of our waste management recirculation program and the circular economy program. So that is also happening in India to a greater extent. Next. Same. That the photographs which shows mostly the biogas plant, it is a 20-ton biogas plant which is in Indore, and this is a waste to energy. Of course, the waste to energy incineration plant are very less in number in India, around 4 waste to energy plant which are running. But most of the waste to energy plant here are the biomethanation plant as well as the co-processing plant. Next, there are a number of AFR, there are a number of MRF, where the dry waste, collected dry waste are separated, and you know that the separation is done manually. You can see the top photograph on the left is the manual segregation, as well as on the right there are automatic segregation. So on the below you will find that the CD waste recycling, and from the CD waste there are a number of products which are produced, and it has a very good market in India. Next. And there is another program in India which is the bioremediation of the existing landfill process, landfill sites. So NGT, this is a special court. So they have given the National Green Tribunal, they have given the mandate to all the municipalities that whatever old landfill sites are there, they have to convert it, and they are to do the bioremediation for the recirculation of the legacy waste which are there. So it is a running process which are there. Apart from that, in Swachh Bharat mission, sanitation is one of the very important issue. That's cleanliness and sanitation in the villages as well as the cities, that reduced the marine littering to a greater extent, and there are number of rules which is now controlling the marine littering possibilities of plastics and other material by the citizen. Next. And there are a number of technologies which are now placed in India. These are all processing in technology, and these are all beneficial technology. These are all giving a lot of employment in India. So as a matter of fact, the whole story boils down to that resource consumption must be reduced in all the countries. We must comply with the requirements of Sustainable Development 2030, and resource efficiency need to be enhanced in all the countries by implementing 3R and circular economy. And of course, India is now at an advanced stage of implementation of circular economy and 3R. With this, I like to thank all the participants, and I must thank Mr. Arisman for giving me the opportunity to speak on this. Thank you.
Yeah. Okay. Thank you, Prof. Sadan. Now we move to Prof. Takamura. Prof. Takamura. Yes. Okay. I would like to introduce Prof. Takamura. She's a professor at Institute of Future Initiative, the University of Tokyo, the Tokyo University, and also Vice President of the Science Council in Japan. Please, Prof. Takamura, the time is yours.
Yeah, thank you, Arisman, and also thank you very much for providing me such a wonderful opportunity to speak on the circular economy. Especially, I'd like to talk about the current status of Japan's policy toward realizing circular economy. And I think my internet status is not so stable, so that I turn off my video, but I hope that we can.
Yes, it's okay.
Yeah. So the my presentation is somehow the I'm going to talk about some kind of general concept of circular economy first briefly, and then I move on to the Japan's policy with a focus on plastic issues. Oh, I'm sorry. So that is the topic. So actually, I pick up this figure from the strategy for the strategy of state of Ontario, Canada. I think this concept is quite similar to Japanese one. So the idea is that we try to shift a linear process, make, use, dispose process to circular economy. So we try to minimize the use of raw material, and then for doing so, we pay attention to the how to make design of the product, and also the production processes. And also, of course, the very in line with the conventional waste management policy. Of course, we try to do maximize the recycling and the use. And finally, together with such, the action, that we try to minimize the waste generated in the end. So the of course the to in with view to achieving such the circular economy, we need the effort of each the actors. For instance, government need to take a leadership, and also producer take a responsibility of their own product and the production process. And the consumer as well, and consumer have to pay attention to it's their activity, their action or their choices of product. So the maybe government and producer together with the consumer try to enhance the awareness of this circular economy. That is, I think, the basic concept. This is how can I say I just write in text circular economy, as I said, that minimizing the use of raw material, maximizing the use of life of material through the resource recovery and other the use and the recycling, and to minimize waste generated. I think a very important point is that some kind of shift from the traditional waste management to circular economy, as Professor Gash mentioned, that it's not only to protect the environment, but also the circular economy concept help business stay competitive and also drive innovation. So for instance, I pick up some example here, and of course, the circular economy protects the environment. For instance, one example is try to reduce the methane emissions or the emission from the waste management process. But also, I like to highlight that the second point, the circular economy how to stay competitive. I think I try to show you the example relating to the plastic issues, but business can minimize cost and maximize diversion by leveraging economy of scale to find the most efficient way of recovering material and returning increased volume of recovery material back into the economy. That provide an economic benefit to the actor, business or economic actor in their business, in their business itself. Then I quickly move to the Japanese waste management law and policy. Actually, it date quite older time. The first comprehensive waste management law was enacted in 1971. That means that already 50 years ago. But I think this law was modernized by adopting additional fundamental law in 2000. Fundamental law for establishing a sound material cycle society was enacted actually 20 years ago. This fundamental law actually contained the basic sense of circular economy. For instance, as I show you, this fundamental law stipulate that 3 pillars: minimizing waste generated, recycling, recovery, and sound disposal of waste. And also, like European countries, we established some kind of hierarchy or priority of the waste management. First, waste minimizing or preventing the waste generation, and then reuse, recycling, recovery, and then after the thermal and energy recovery to come. And finally, if we could not, deal with some residue with such means, of course, the last resort is sound disposal. Our waste management law and policy was quite clearly divided, according to the domestic waste and industrial waste. Domestic waste is under responsibility of local government. You might know, as you might know, that the system of separation and the collection, especially of the domestic waste, I mean the waste from the household, was relatively good. And one of the problem is that the large share of the domestic waste go into incineration. One reason is that due to the constraint of the disposal site, but I think I'll show you that case of plastic later. For some product, we establish recycling system. For example, for batteries, a producer have a responsibility to establish collection system and do recycling and disposal in collaboration with retailers. And another example is the electric appliances. We pay some disposal fee, when we buy these product, and retailers do then collection of the electric appliance waste when they do delivery of new one. So that is an example, but it is specific to some type of product, not applied to all product waste. So the on the last second category is, as I said, the industrial waste and waste from not how can I say from other place than the household. That is on the responsibility of waste emitters and businesses usually. So they have to do the recycling and the use, and the end they have to dispose in a sound way. So I'm going to talk about specifically on plastic waste. I think that is already shown by the Professor Gauch. Then I skip here. And of course, the plastic issue is started with a marine litter problem. But if we look at the source of emission, as you know, that comes from land. Then that is a problem of land-based marine pollution. So when we look at the plastic production globally, since the 1950s, growth in the production plastic are largely outpaced that of any other material. Actually, the world produces more than 400 million tons of plastic every year. And if this growth rate continue by 2050, the plastic industry may account for 20% of world total oil consumption. Then here you can see that this plastic issue was very clearly linked with the climate change issues. So if we look at the distribution of the especially single-use plastic production, actually the Asia is one of the center. Especially I have to say that Northeast Asia is the one of the largest, production of the single-use plastic. That is a trend of the plastic waste generation. I think here, and half coming from Asia. In case of Japan, we have, the relatively small, packaging waste generator. But if we calculate the per capita packaging waste generation, we are the second after the US. United States together with the European Union. So that's I think the reducing packaging waste in plastic packaging waste, or more generally plastic waste, is one of our priority of Japan. So that is material for plastics in Japan. I think that's the figure that I wish to show you here. If you look at the use of waste generation, we annually produce the 9,400 kiloton as plastic waste. The half come from the packaging container waste, And if you look at the collection part, it's really interesting to see that there is no single legislation on plastic, and the collection was made according to the appliance or product. So the last point that I'd like to highlight is the recycling and treatment part. We, as I said, that do establish quite a good collection and the separation system, but recycling in material recycling is only 25% of the waste, plastic waste. More than half go to the energy recovery process. And then the unutilized plastic waste is still remain around 20%. So that showed our challenge of the plastic waste issue. So that how to increase in the material recycling and chemical recycling, and also how to reduce the non-recycled plastic waste. It's really tiny text. I'm sorry for this. This is the our outline of the resource circulation strategy for plastics. We established this the strategy actually in last year. So we established a very important principle is the 3R. 3R reduction and reuse and recycling, and renewable is also the one of the important point. Renewable means that the especially talking about material, or we seek this some kind of alternative material for plastic, especially based on renewable material. So if you look at the milestones, we have some milestone by 2025 or 2030 or 2035. For instance, we have a target milestone to reduce cumulative use of single plastic. We try to reduce by 2030 reduce the comprehensive single-use plastic by 25%. And also we try to increase the reuse and recycle, and especially we by 2035, 100% of the plastic used should be recycled and reused. So also we have a material-based target, like we introduced the about 2 million ton of biomass-based plastic by 2030. It's quite difficult to achieve, but that's an incentive to create or innovate the material alternative for the plastic, oil-based plastic, if I may. So we are now still continue to deliberate about how to make strategy and the specific action. But I think we expect that next year we could possibly have one new and comprehensive legislation on plastic. As I show you that currently it's quite a patchwork type of situation exists about legislation. The individual legislation targeting at some specific product. So I say that it's patchwork type of situation. So that we try to create a new and comprehensive legislation on plastic to make comprehensive management of plastic issues. And maybe quite a new and in line with the circular economy is that, of course, we continue to enhance reuse, recycling, sound disposal, but very important, new point, if I may. We now focus on product design and the production process. So possibly under the new legislation on plastic, we established some guideline for design of product to enhance the reducing the use of plastic, and also enhance the alternative for the plastic use. As I said, that the innovation for alternative material is another point, especially biomass-based plastics. So lastly, I think we focus, our policy focus is also on the international collaboration. Because the protecting the environment and the ocean it's a global issue for all countries, and especially important for us, Japan, as a maritime nation. I think it's quite similar to Indonesia. And of course, this is a part of one of the goal and of the Sustainable Development Goals. And last year, with the participation of G20 countries, G20 leaders, also the Blue Ocean Vision was agreed. We aim to reduce additional pollution by marine plastic litter to 0 by 2050. But the last point that I like to really highlight is that now Japanese business is quite active, and the business consider that the settling or providing solution to plastic issue is of utmost important, because they consider that that kind of action, improve their competitiveness and resilience through cost efficiency and resource efficiency. Imagine that Japan import, remind that the Japan import oil, most of oil from, overseas, so that continuing, the use of plastic is, we continue to depend on the imported oil, so that I think the change of course could, reduce the cost and also the dependency on oil. And then we could enhance resilience. So also business see that this is a good opportunity for the creating new market and businesses. The last point in the context of Japanese business active action is that they consider that these active action enhance corporate value in the market, financial market, and supply chain. Maybe you might know that in the context of climate change, now the investors try to request the businesses to integrate climate consideration or climate risk consideration in business strategy and decision making. So the G20 Financial Stability Board established some guideline called TCFD, and the investor based on this disclosure by the businesses, they invest, often called ESG investing. So the investor also, request the businesses to reduce emission, not only of its own business, but also over its supply chain, value chain. You can see that the ESG investing is increased first Europe and then North America, but at the same time now in Japan see quite a good increase in the ESG investing. Probably that go to the other area of the globe. So this kind of approach is now spreading. I think I show you in the slide that for instance, the September 2018, already one of the biggest asset owner, Norwegian governmental pension fund, request the businesses or the business, the target, it's a target for their investing, integrate consideration marine plastic issue into their business strategy. So actually this trend expand, that this is the last slide. That is come from the Morgan Stanley research last year. The individual investors show the most interesting target in climate change, of course, but at the same time, plastic reduction and the circular economy. So then that's why the Japanese business needs now see that that's a big chance opportunity for their businesses, and also they seek the collaboration with other businesses in other countries. So that I think that is some kind of chance for the international collaboration to enhance the sustainable recovery from the COVID-19. Thank you very much. It's the end of my presentation.
Yeah, thank you, Prof. Takamura. Yes. Yeah. After we hear from all the presenters, based on my understanding that when we're talking about circular economy, there's two key important issues here, like how to, well, the first one is resource efficiency, the second one is how to reduce waste and pollution. Like Indonesia itself, based on the preliminary study by UNDP in 2020, there is 5 key sectors can contribute to the potential of implementing of circular economy in Indonesia. The first sector is F&B, food and beverage. The second one is textile, construction. The third one, and the fourth one is plastic packaging, and of course the electronic industry. This is based on the UNDP can contribute around 41.6 billion US dollars in 2030. Listening from the all speakers, like from Prof. Michelle mentioned about circular smart city and how to incorporate ICT or digital technology to circular economy. But I would like to take this question from the participant. The first for Professor Takamura. The question is, how is the role of EPR or extended producer responsibility to circular economy? What are the experience of Japan? This question also goes to India after this to Prof. Sadan. I give the chance for Prof. Takamura first. Thank you.
Thank you very much, Harrison. That is quite an interesting question because unfortunately we couldn't find any word of expanded, the producer responsibility in our legislations. It's maybe surprising, but as I show you some example, already under the individual legislation on, for instance, battery and electric appliances, a producer have to establish some recycling and reuse system and disposal system, and sometimes they have to bear the cost of it. But it's not told. I have to say that it's not somehow the say integral system. I mean, it's quite a case by case of product. So that is, I think, one of the challenge for our, the waste management law. That's why it's really important question, I think.
Yeah. So the second question is related to plastic issues. How you look at this one from the consumer side? How Japan society, how they change their behavior related to this plastic using plastic, because it's very challenging, right? To shifting from, let's say, using straw to not using straw or plastic cutleries, and this kind of, we especially in the COVID condition of everything plastic packaging when you send the food delivery to your home. So please, maybe you can share your opinion, Prof. Takamura.
Wonderful question. I think the COVID-19 had somehow that adverse impact of behavior change because of course, some essential use such as a medical product. As the plastic is quite useful. Sometimes we couldn't find an alternative. So that maybe the Japanese population then the mindset might be somehow reluctant to change their behavior and try to come back to the single use of plastics. But we had to clarify it in our strategy, and also the deliberation, because of course there are some type of essential, the plastic issue which are subject to essential use. But since for these such product for the essential use, we need really innovation for alternative. So we put more focus on innovation, especially for the product that currently we have no alternative. And behavior change, second point on behavior change, even during the COVID-19, we introduced some kind of levy on the shopping bag in plastic.
Okay.
Actually, that was quite effective. Some data show that now the 80% of the buyer in the supermarket and convenience store decline the offer of the having a plastic. So I think there's some kind of economic instrument like levies, fees is quite effective to change the behavior, vis-a-vis plastic product. But we are still try to the learning. We are still in the learning doing by learning process. So that's But I think that is most recent discovery on this point.
Yeah, thank you, Prof. Takamura.
Thank you.
There's a question for Prof. Sadan. Prof. Sadan, you are with us. Hopefully, Prof. Sadan. Prof. Sadan, okay, if maybe we can have another question for Prof. Takamura. One more question related to the this is the question from Indonesia as well. Do you think economy can enhance local production to contribute in a global value change? Yeah, maybe this is the last question for you.
Yeah. Sorry, I think because of internet, could you please repeat your question? I think I couldn't hear clearly.
Yeah.
I think I turned off.
Question from the participant. The question is, do you think circular economy can enhance local production to contribute in global value change?
That is a question. I think I could say yes and no.
Oh, okay.
I think in principle, I think the question is yes, because we try to reduce the impact on environment from the production process. So I think how can I say, the long distance transport is not so welcomed and preferred. So I think local production, maybe together with the COVID-19 reaction responses, I think somehow the circular economy enhance the local production. But the reason why that I say that maybe no, because we have to really pay attention to that. Seeking alternative. Sometimes we procure something from the outside of country. Some Japanese company, for instance, now they seek the biomass overseas. So in that case, I think the seeking alternative might change. They do some cost change. Rather the focusing on local production. Rather than local production. But I think yes.
Yes and no. Yeah, okay. Thank you, Prof. Takamura.
Thank you very much.
Now there's another. Thank you so much. For Prof. Michelle, can you turn on your video, Prof. Michelle? Yes. There's a question goes to you related to how to connect the ICT with waste management in order to support the implementation of circular economy. Because in your presentation, you are talking about digital technology, how to, link up with the ICT to the waste management, let's say, and also to the waste management in the circular city, something like that.
Yeah, I don't have any explicit examples here, but connecting waste to the digital technology element is going to be important. I'm not sure I can answer that question on the run like this, but I think the DCT technology helps us to connect our consumption and production habits, how we connect from a consumption point of view is more difficult, perhaps from a production point of view via the blockchain, and that it might be enabled more easily. But most of our waste efforts really are connected at the moment through the local government, through the collection systems and the resource recovery systems that we've got in place. It really isn't that digitalized.
Okay. Yeah, the second question is related to circular city, a circular or smart city. Which city in Australia already apply this concept, the circular city? I mean, in the full concept. Can you give example of the concept of circular city in Australia? I mean, which city?
The whole concept of circular city is in development. So there's no one city that's starting to pick up on it. It's just an awareness. I think there are architects and designers, construction companies who are much more focused on compact design living at the moment, particularly in Victoria, I think. And I think carpooling and car sharing is often being promoted by companies to their employees increasingly. And I think there's a lot more of that in New South Wales than perhaps is done here in Western Australia. I think the circularising of the waste and the water and energy efficiency is something, though, that each city is trying to focus on at some level. But the perfect design for the circular city is a project that's currently being planned and developed, I guess.
Yeah. Maybe the last one, what are the challenges on implement the circular economy in your respective country?
There's lots of challenges, I guess. One, having the digital technology, like the first question is suggesting, that connects to all our points of production and consumption. Secondly, then having the resources, to create those systems that enable us to measure and manage them. I think an increasing commitment to waste management, resource recovery, recycling is necessary. That's certainly increasing, but we need a lot more of it. And I think also, it'd be really great if we could see, as was picked up in Professor Takamura's last couple of slides, the whole idea of eco-design and the point of planning for some of the changes we need to make in terms of forming the zero waste equation is really critically important from both a production point of view and increasingly from a consumption point of view. But in our engineering schools, starting to look at the importance of eco-design as a way of teaching engineers to start with the circular model in mind in the first place is critical.
Yeah. Thank you, Prof. Michelle. Yeah. Actually, there is a question for Prof. Sadan, host, but looks like he's also leave because of, I don't know, because of the internet connection, or there's that question also from the Denmark about how come the cement industry is sustainable, and then I think because of the because based on the question here from Denmark, that the cement industry is not circular because the energy recovery of the resources cannot be used again. So unfortunately, Prof. Sadan not with us now, but yeah, you can contact and discuss with him by email. I would like to appreciate all the participants to join this webinar. Actually, this webinar is only for the preliminary discussion for circular economy, especially this concept is quite new and how to put it in the practice. Like I mentioned earlier, Indonesia is one of the quite active in promoting this concept as well, because again, our National Development Agency, Bappenas, put it in national priority, especially like the 5 key sectors like I mentioned. It's quite interesting discussion today from a very broad topic from cement industry, plastic industry, as well as how to link up from the digital technology to the circular economy in the context of municipalities. I would like to again thank you for all the presenters, the speakers, and also the participants. look forward for another webinar with us. Thank you so much, Prof. Michelle and Prof. Takamura and Prof. Sadan Bose. Thank you so much. See you again. Thank you so much. Thank you, Prof. Takamura. Thank you so much. Thank you, Prof. Michelle. Yeah, look forward to meet you again. Thank you so much.
Thank you, Arisman.
Yeah.